Good morning, everyone. Thank you for joining us from the People's Republic of California. We're glad that you're here. I'm Steve.
And I'm Scott.
Together, we're Backyard Musings, the science and technology channel.
And we are talking today about a newfangled zipper. And before you leave us, stick with us because this is a very interesting item for clothing.
Very interesting.
Yep.
Yeah. A decades-old patent from MIT Professor Bill Freeman inspired the new Y zipper. And if you could just imagine a Y, that's exactly what it looks like. A three-sided fastener that can snap gear, robots, and art into shape with the push of a button. Long before shape-shifting robots and self-assembling structures became engineering goals, one MIT professor had already imagined a zipper that could transform floppy materials into rigid forms on demand. Imagine a tent, a pop-up tent,
Right.
And the zipper can help structurally keep it up. The problem? In 1985, the technology needed to build it simply didn't exist. Would you like to know more?
Okay, that year, the Innovative Design Fund placed an ad in Scientific American offering up to $10,000 for inventive ideas in clothing, textiles, and home design. William Freeman, PhD, and I'm going to say that's class of 92 probably, then an electrical engineer at Polaroid and now an MIT professor, he got smart, responded with an unusual concept, a three-sided zipper that can make objects instantly switch between soft and stiff states. Instead of fastening jackets or pants, Freeman envisioned it helping items like tents, chairs, and bags collapse flat for transport and then unlock themselves into sturdy 3D structures when zipped together.
I don't know about a chair. I mean, what if a big guy sat in a chair? It would just crumble, wouldn't it?
Well, I don't know. Maybe it's got some kind of framework to it, like those collapsible banana chairs and stuff now. I don't know.
Yeah, maybe.
Yeah.
Yeah.
We'd have to see more on that one.
His prototype looked like a triangular version of a conventional zipper. 3 flexible strips lined with narrow wooden teeth could be drawn together by a sliding mechanism forming a rigid triangular tube. Kind of like the ones where you'd ship like drawings or a painting, that triangular tube. The idea was rejected, but Freeman patented the invention and stored the prototype in his garage, convinced it might someday find a purpose.
Wow. Okay. Nearly 4 decades later, researchers at MIT's Computer Science and Artificial Intelligence Laboratory, or CSAIL, returned to the idea as they looked for ways to create objects with tunable stiffness. Okay. Earlier methods for changing stiffness were either difficult to reverse or required assembly by hand. CSAIL responded by creating both an automated design tool and an adaptable fastener called the Y zipper.
The software lets users design customized 3-sided zippers, which are then fabricated automatically with plastics in a 3D printer. The resulting fasteners can be attached to or built into camping equipment, medical devices, robots, and art installations to make assembly easier. It's like an easel almost, right? An easel.
Okay. Quote, a regular zipper is great for closing up flat objects like a jacket or pants, right? We use those all the time.
Yeah.
But Freeman ideated something more dynamic. Using current fabrication technology, his mechanism can transform more complex items, says MIT postdoc and CSAIL researcher Jiaji Li.
Jumanji? Did you say Jumanji?
I said Jiaji.
Oh, Jiaji.
G-I-A-G-I, or J-I. Okay. Li, or Li. Li, right?
Li.
Who is a lead author on an open access paper presenting the project. Going on with a quote from, I guess he's still a doctor, right? Dr. Li.
Jumanji Li, yeah.
We've developed a process that builds objects you can rapidly shift from flexible to rigid, and you can be confident they'll work in the real world, unquote.
So you can be confident. Trust in us. In CSAIL software, users can decide what the fastener will look like once it is closed. They can set the length of each strip and choose the direction and angle of its bends. They can also select from 4 basic motion patterns that determine the closed shape: straight, bent like an arch, coiled like a spring, or twisted like screws.
Wow.
Yeah.
I'd like to see this. I'd like to see this in action. The finished Y zipper appears to change shape in the physical world. When open, it can spread out like a squid with 3 extended tentacles.
Okay, I can see that.
You can? Okay.
Yep.
When zipped shut, it pulls into a tighter structure like a rod, for instance. That flexibility could be useful for travel and outdoor gear. Pitching a tent alone can take up to 6 minutes, but with help from the Y zipper, the process could take 1 minute and 20 seconds.
That's 600% more efficient, right?
That's
500%?
saving a lot of time for fishing or hiking or bird watching.
Yeah.
You do when you're camping. Each arm attaches to a side of a tent, supporting the structure from above, so the fastener effectively snaps the canopy into place.
That smooth shift between soft and rigid states could also help create more adjustable wearables, especially for medical use. Oh yeah, like a biohazard suit. Just zip, zip, and it fits around you. Especially for medical use. The team wrapped a Y zipper around a wrist cast so the wearer could loosen it during the day and close it at night to help prevent further injury. In that setup, a device that normally feels rigid can become more adaptable to a patient's comfort and needs.
So I wonder if you could use this when you just said that wearable. I wonder if you could use this. Let's say you're down in the Congo or wherever they're having issues with mosquitoes and malaria.
Oh yeah.
Instead of dealing with a whole big old net over your bed, you just go to sleep wherever you need to, wearing this Y zippered suit, so you're protected all the time. All right, the system can also help technology that moves with the press of a button. After fabrication, a motor can be attached to the Y zipper. Oh, to automate the closing process. Wow, okay. The researchers used this approach to make an adaptive robotic quadruped.
Yeah, quadruped.
Okay. Such a robot could one day change the length of its legs. Oh, now we're getting into transformer type stuff, right?
Yeah.
Pulling itself into taller limbs or opening the fasteners to stay close to the ground. Fast shape changes like these could help robots move across uneven environments such as canyons or forests. Military, right?
Yeah.
Motor-driven Y zippers can also create moving art installations. Okay, I'm not big deal. In one example, the team built a long winding flower that bloomed when a stationary motor zipped the device closed. Interesting.
Jumanji Lee and his colleagues saw many possible uses for the Y zipper, but they still needed to test whether it could hold up under repeated use. The team began with stress tests. They compared polylactic acid, PLA, and thermoplastic polyurethane, TPU, 2 plastics commonly used in 3D printing. A machine bent the Y zippers downward, showing that PLA could carry heavier loads while TPU was more flexible.
In a separate test, C-Sail researchers used an actuator to repeatedly open and close the fastener until it failed. Okay, now we're going into the fail test. The Y zipper finally broke after about 18,000 cycles. So that would be an open and a close would be one cycle, right? Or maybe an open, a close, and an open. Anyway, according to 3D simulations, its durability comes from its elastic structure, which spreads stress more evenly under heavy loads.
Even with those results, Jumanji Lee sees room for a stronger version made from tougher materials such as metal. The team may also scale the zippers up for larger projects, although their current 3D printing system cannot yet produce that size. Lee also points to...
Go ahead.
Oh, that's yours.
No, that's all right. Go ahead.
Lee also points to uses that remain largely unexplored. In space exploration, Y zipper arms could be integrated into a spacecraft and used to collect nearby rock samples, or like grabbing asteroids that are floating out there. You know, when you're in a mining situation, you're trying to grab all the asteroids you can. Similar fasteners could also be built into structures designed for rapid assembly, helping relief teams quickly deploy shelters or medical tents after disasters or during rescue operations.
Yeah.
Sounds like the next thing since sliced bread, you know?
Yeah, probably a lot easier to pack in structures or tents or shelters or whatever.
Especially if it's lightweight,
Yep, and
like
it's
plastic.
flat. You could stack several up on top of each other on a truck or a what do you call those little quads that you rich folks get to go around hunting in and stuff.
You could
Stack
probably
several
use
of
it to
those
put,
on there.
you could probably use it to put your fishing pole on after you cast. Right? Just set it down in like a Y thing. Yeah.
Sure. Yeah. Or be protected from mosquitoes while you're fishing.
Yeah.
Still fish.
Yeah.
I wonder if we could get a hold of the marketing department of this company and see what they'll take some of our ideas. So anyway, good story. Very kind of cool. Yeah.
All right.
Very
Thanks for joining us, folks.
scientific.
We'll see ya.
Okay. Take care. See you this afternoon. Thanks.